In this lesson, we are going to study effects of horizontal shift on elements of the graph. We are given one graph f of x is equal to x square, which is a base graph, and then we will do two horizontal shifts in graph g of x and h of x, and we will see how the elements of graph are affected. To save time, we have produced table of values with range of values of x wide enough to accommodate y values of the base graph from 9 to 9 in g of x and h of x. So let's use this table of values for the first base graph y is equal to x square and plot this on the grid. Here the first pair of value that we are going to plot is minus 3, 9. So minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the first point. And the second point would be, so let's write down the coordinates, minus 3 and 9. The next point would be minus 2, 4. So 1, 2, 3, and 4, that is right here. Minus 2, 4. This is the point. And minus 1, 1 is this point. Minus 1, 1. 0, 0. And because of the symmetry of the graph about y-axis, we have this point here, and then this point here. So this is 3, 9. This is 2, 4. And this is 1, 1. And this obviously is the origin with coordinates 0, 0. As we have produced this graph before, in previous question, we can smoothly draw the graph with freehand, and this is the graph that is produced. There you go. So this is the graph, and its equation or its function is written as f of x equal to x square. Now let's take a look on the first horizontal shift, which is g of x equal to x plus 1 whole square. X plus 1 whole square tells us it's a horizontal shift inside the square, and positive sign mean x will be shifted toward left. If it was negative, so positive mean shift to left, and the negative means shift to right by 2 units, and here shift to left by 1 unit. So keeping y values same, now we are going to shift x values toward left by 1 unit in case of g of x, because here the horizontal shift is plus 1. So let's shift these values. This 0, 0 will be shifted by 1 unit. So this will come here, and this point will be here, this point will be here, this point will be here. Everything will be shifted by 1 unit toward left. So this is here and this is here. If this is x plus 1, again shift the entire graph toward left by 1 unit, or whatever the number that is indicated there, and draw the new graph. So this is the new graph that is being produced. And there we go. So this is the graph for g of x is equal to x plus 1. This is g of x equal to x plus 1. Remember, this is opposite to the vertical shift. In vertical shift, if this was a positive sign, the graph would move up. For negative sign, it will move down. But for horizontal shift, if a number is being added, a positive like plus 1, the graph moves toward left by that unit, by that number. And if it is minus 2, then the graph will move toward right by the amount the number is given there. For example, now h of x is given x minus 2 whole square. And x minus 2 whole square means that now we are going to move the graph toward right by 2 units. So look at the base graph and move all the points by 2 units. So here the origin, that is being shifted toward right by 2 units, and this point 1 1 is being shifted toward right by 2 units, 2 4 is being shifted toward right by 2 units, and 3 9 is being shifted toward right by 2 units. And these are the points. And now minus 1 1 is being shifted. Minus 1 1 is being shifted toward right by 2 units. So this will come right here. And minus 2 4 is being shifted toward right by 2 units. That will just come on the y-axis. And minus 3 9 on the base graph will be shifted toward right by 2 units, and that will be right here. So now let's draw the new graph, and this new graph will be here. This is here, and it's not the perfect graph, but that at least tells the nature of the curve, and that is on this side. So this is the new graph, that is for h of x. h of x, and that was equal to x minus 2 whole square. So now you learned the trick that for generalization is for base graph y is equal to x square, y is equal to x minus h whole square means that base graph y is equal to x square is being shifted to right, is being shifted toward right by h units for h is greater than 0. And otherwise, if it was x plus h, then obviously it will go the opposite way. And if y is equal to x plus h, then base graph y is equal to x plus x square will shift toward left, will shift toward left by h units, h being positive again. So this is how the horizontal translation or horizontal shift works. We'll now take a look on the elements of the graph, like how it affects the different properties of the graph. For graph, for g of x equal to x plus 1 whole square. Let's take a look on the graph, and we know that shape remains same. Whether it's horizontal shift or vertical shift, the shape of graph doesn't change. So that is for sure. And now number 2, we are going to take a look on the vertex. Vertex for f of x, which was equal to x square, g of x, which was equal to x plus 1 whole square, and h of x, which was equal to x minus 2 whole square. How the vertex is, this vertex is 0, 0, we know that. And for g of x, which moved toward left by 1 unit, its vertex is now minus 1, 0. Its vertex is now minus 1, 0. Now here you can imagine that the trick is that find the value of x as if x plus 1 was equal to 0. That will give you the x coordinate of the vertex. And similarly, for vertex of h of x equal to 2, this will be equal to 2, 0. Because if we take a look on x minus 2 equal to 0, this gives x equal to 2. And because there is no k, if there was plus k, that would provide the second coordinate for the vertex. But because k is 0 in all 3 cases, therefore the y coordinate of the vertex is 0 in all 3 cases. And number 3, third property is axis of symmetry. Axis of symmetry. And we already know the trick. The trick is that just put the square term equal to 0. So axis of symmetry for f of x equal to x square, g of x equal to x plus 1 whole square, and h of x equal to x minus 2 whole square. If we put the square term equal to 0, this means x square equal to 0. I mean x equal to 0 or y-axis. Y-axis is the axis of symmetry. And here, if we follow the same principle, it means x plus 1 square is equal to 0. Means x plus 1 equal to 0 or x equal to minus 1 is the axis of symmetry. Is axis of symmetry. And for this, the axis of symmetry is x minus 2 equal to 0 mean x equal to 2. This is the axis of symmetry. So now you are comfortable finding vertex and axis of symmetry. And similarly, now if you want to find out the intercepts for x-intercept, f of x equal to 0, here for this was for f of x equal to x square, this was for g of x equal to x plus 1 whole square, and here for h of x equal to x minus 2 whole square. Whenever we want to find out x-intercept, put f of x equal to 0, here g of x equal to 0, and here h of x equal to 0. So this gives x equal to 0 in this case, and here we get x plus 1 equal to 0 means x equal to minus 1, and here we get x minus 2 whole square equal to 0. This means x is equal to 2. So for this, x-intercept is 0, 0. For this is minus 1, 0, minus 1, 0. And for this, it's 2, 0. 2, 0. Similarly, if we want to find out y-intercept, for y-intercept, put x equal to 0 for f of x, which is in fact equal to y, is equal to 0, means 0, 0 is y-intercept. And for g of x, if we put x equal to 0, this means g of x, which is in fact y is equal to g of x, is equal to 0 plus 1 whole square. That would be equal to, this means y would be equal to 1. So 0, 1 is y-intercept for this. And for h of x, y is equal to h of x equal to 0 minus 2 square. Here, because we put x equal to 0 at x equal to 0 and at x equal to 0, y is equal to 4. So this would be 0, 4. That would be y-intercept in this case. Similarly, if we want to find out focus or focal length, focal length is in fact 1 by 4 time coefficient of x square, and that is 1. So 1 by 4 times 1 is equal to 1 by 4. So that is the focal length for all functions, for all f of x, g of x, and h of x. We can find out the value for directrix. Equation directrix is y is equal to minus 1 by 4. That is the y coordinate of vertex minus 1 by minus focal length. So this is 0. Y coordinate for vertex in each of these cases is equal to 0. Therefore, this would be equal to y equal to minus 1 by 4. This will be equation of directrix for f of x, g of x, and h of x, because 0 is because y coordinate of y coordinate of vertex is 0 in all three cases. And finally, equation of lattice rectum. That is y equal to y coordinate of vertex, plus focal length. So that will be equal to 0 plus 1 by 4 in this case. I mean y is equal to 1 by 4 for all f of x, g of x, and h of x. Although these properties are not required for grade 11, but it's nice to know about these properties. And in fact, as we move further in these functions and the study of functions, we are going to bring in more properties of parabola and quadratic functions.